Good day everyone. I'm Michael. And I'm using a text-to-speech program to have a more clear speech and audio. In this video lesson, you will learn the following. 1. Create a Xamarin Forms grid in code behind. 2. Recognize the difference between creating grid in XAML versus in code behind. Now, let's open our Visual Studio and do some coding. For this demonstration, we will be going to create the grid element in our code behind. I already created the project and name it grid in code. Let's delete the initial content in XAML file. Go to the code behind and create a new instance of the grid and name it my grid. Then sets its properties. Now let's define the row and column definition of the grid. Inside these brackets, we will add 4 row definitions to modify the height of the rows. To do that, we need to create a new instance for each definition. Then open and close curly brackets. We set the height of the row. Take a look at how we set the height of the row in code, compared to XAML. In XAML, we just pass a string value. And these string values will automatically convert into primitive data type or object type using a type converter. But in C# code, we need to define it according to its type. Let's dig more into this syntax. In Visual Studio, there is a feature that allows the user to view the documentation or definition of a particular object or data. For example, this height property. We just need to hover the mouse pointer to it. Then right-click. Then select Peak Definition or go to Definition. This will lead us to the definition of the object. As you can see, the type of height property is a type of grid length. That's why we need to assign value to it with a grid length type. Unlike in XAML that we directly pass a string value to it. Let's also peek at the definition of the grid length. As you can see, it has 2 constructors. This one has 1 parameter. And this one has 2 parameters. One of which is a type of grid unit type. Let's also check the definition for grid unit type. So this type is an enumeration type. With a value of absolute that is assigned to 0, star assigns to 1, and auto that is assigned to 2. So you see guys, this feature of the Visual Studio is very helpful, especially if you are not familiar with the object or want to understand more about a particular object. Now let's complete the definition of our grid element. We can now add the children element of the grid or the cells of the grid. So this is the output we need to achieve. It has a total number of 8 cells. This cell has a column span of 3. And this cell has a row span of 3. Let's go back to our code behind and add the children element. We've now created the labels, we can now add them to the grid element. If you look at the description of the method, this method has 3 overloads. One has 1 argument. And this will require you to add the view. The view is the element we would like to add, in this case, the label. What we are going to use is the method with 3 arguments, such as view, left, and right. Left refers to the column and right refers to the row. Let's input the elements and their position in the grid. Then assign this grid to content. Let's run the app first before we set the row and column span to see how it looks without the span. This is the output without the span. I forgot to set the background of the grid so that we can see more clearly the boundary of each cell. So let's change its background to green. Then, reload the app. As you can see, it has as empty space in the grid. Let's go back to the code and set the row span of label 8 and column span of label 4. The row span is a bindable property, and it is a static property, meaning it cannot be instantiated. So we need to call the grid class and call its property. Then we pass the view or the element we would like to set the span. Then the number of rows the cell will consume. The syntax for setting column span is similar to row span. Type grid.setColumn. Then reload the app again. There it is, we have now created the same UI like what we did in XAML. That's how we create the grid using C# code. If you notice, the user interface in XAML is much simpler and cleaner than in code behind. But I'm not saying the code behind is bad. There are times that the code behind is more logical answer to the problem. For example, if you want to create a calendar, you cannot hard code all the months and days inside the XAML. While in code behind, we can use loops and arrays to simplify the solution. Ideally, we can use both XAML and code behind to create a more dynamic and user-friendly UI. That's all for this video lesson. If you have questions, suggestions, something to add, or you think something is missing or incorrect to the lesson, please let me know. Again, this is Michael, thank you and see you at my next video lesson. Keep safe everyone.